So for this one, the city's population was 198,000 in the year 2003. The population has been decreasing at a continuous rate of 4.9% per year. I'll try to remember that this one's decreasing on this one. Again, the only thing that makes, the reason why that's significant is because the rate is negative. Okay, so it's decreasing at 4.9% per year. What is the population in the year 2014? All right. So they didn't give us directly what the T is on this one. Oh, they did give us the K, which is the rate, and they directly gave us the initial value, which is the population in the year 2003. Okay, so I'm actually going to fill those in while I can, or while I remember. So that's our initial population there, 198,000. And the E, remember, that's a Euler's constant, so we're just going to write that E out, and then the rate as well. Now, if you're using the calculator, which I recommend, you could just put 4.9%. Okay, but since I'm not using a calculator necessarily right now, I'm going to change this into a decimal by moving the decimal 2 times to the left, making that 0.049 as my rate. Okay, so that's my K, which is the rate, 0.049. All right, that's kind of small. And then the T value, that's our time. It's from 2014 to 2003. So I'm just subtracting those two, really. 2014 minus 2003. And you see you get 11 years on that, okay? So that's my time. 11 years. Oh, see, I almost forgot already. That's a negative. I know, right? So that's a negative rate on that one. Now, if by chance I had left that positive, I would have made the same mistake that I did in class when we did this type of problem. And I would have just noticed that the population is bigger than what it started at, where this one says it's decreasing. So then I would have noticed to go back, just like we did in class, to make that negative, okay? So, so now to make this full-blown function notation, right? It's really A of t equals this stuff. Just that now we know the time is in 11 years. I don't know if that really makes a difference to you, because I'm just going to take this and go directly to my calculator to figure out what the actual value is here. So there we go, 198,000. Now remember, to access E, I got second, and then I push the LN button. It's a natural log, which we haven't had to worry about. So negative 0.049 times, and this is still in the exponent, times 11. I push enter. I get 115,499.5958. I'm going to round that to 60 cents for this one. So all that together, $115,499, and rounded makes that 60 cents. Okay, so this is population. I take that back. I'm not even going to use the decimal on this one. I was thinking of interest again. So I'm going to round that up. Oh, I got to round it up lots of places there. That's going to make that a 500. Okay. And this is population, so that's significant. You don't want partial people. And yeah, before you're like, well, it's just person without legs. That's jacked up. Okay, they're still a person. And we don't want their legs cut off. Okay, so 115,500 people. It almost looks like it says purple, whatever.